Hi class, in today's video we're going to be talking about section 5.2, right triangle trigonometry. And so I'm going to start here with a right triangle, and we'll call that right triangle ABC. That's its vertices, A, B, and C. And this angle here we'll call theta. So that's theta, which we write as a circle with a line through it, and that's a Greek letter. It's a Greek letter that makes the sound TH. So for theta, as long as it's between 0 and 90 degrees, because this one's already 90, and we know that the sum of the angles have to be less than, or are exactly 180. So if I take 180 minus 90, these other two together have to add up to less than 90, right? And so we will define A to be the length of the side opposite theta. And so let me get a color. So A is the length of the side opposite theta. And then B is the length of the side adjacent to theta. And C is the length of our hypotenuse, which is that length opposite our right angle. So we have a few functions that we can define. So for this right triangle, we have what are called the trigonometric, or trig for short, trig functions of an angle theta in a right triangle. So these are only defined for right triangles, hence right triangle trigonometry. Our sine function, which we'll write as sin of theta, is by definition the opposite side over the hypotenuse. Now opposite theta is A, and the hypotenuse is C. And so sine of theta is the ratio A over C. Cosine, abbreviated COS of theta, is our adjacent side over our hypotenuse. So that means we have B over C. And our tangent, abbreviated TAN of theta, is our opposite side over our adjacent side. Opposite over adjacent, which is A over B. So we say the sine of theta is A over C, the cosine of theta is B over C, and the tangent of theta is A over B. And I would say often, because who knows if we're going to use A, B, and C as our variables in a general triangle. It's better to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so we remember this as SOHCAHTOA. SOHCAHTOA. Which really doesn't change us anything. SOHCAHTOA. Because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent. Now these aren't the only ratios we can make in a right triangle. So let me rewrite my right triangle real quick. We have theta, A, B, C, just to keep track of everything. And we had SOHCAHTOA. So sine of theta was opposite over hypotenuse, A over C. Cosine of theta, adjacent over hypotenuse. And TOA, tangent of theta, is A over B. We could also look at these reciprocals. C over A, C over B, and B over A. Now those functions have their own names. This one is called the cosecant, which we abbreviate CSC of theta. The second, the inverse or reciprocal of cosine, is secant, which we abbreviate SEC of theta. And the last is the cotangent, which we abbreviate COT of theta, is B over A. And now note, if we take 1 over A over C, if we multiply the top and the bottom by C over A, we get A over C times C over A gives us 1, C over A. But what was A over C? 1 over A over C is sine of theta. And what was C over A? Cosecant of theta. And so 1 over sine is cosecant of theta. And so that gives us several relationships between sine, cosine, tangent, cosecant, secant, and cotangent. Namely that, and these are called the reciprocal identities, where we have 1 over sine theta equals cosecant of theta. 1 over cosine of theta is secant of theta. And 1 over tangent of theta is cotangent of theta. Now we could multiply both sides by sine to cancel that and divide both sides by cosecant to get the related 1 over cosecant theta is sine of theta. And the same process here, 1 over secant of theta is 1 over cosine of theta. And 1 over cotangent of theta is tangent of theta. So what we need to remember up to this point is we have SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And their reciprocals, cosecant, secant, and cotangent, and they're all connected by these reciprocal identities. And if you want, you could write an equivalent version of these. Multiply that secant over. 1 equals sine theta times cosecant of theta. I think I said secant, but that's definitely sine. Or 1 is cosine theta times secant theta. Or 1 equals tangent theta times cotangent of theta. Right, and we know this to be true because if I borrow my handy dandy reference sheet back here, I'll look at the tangent cotangent. Tangent is A over B. Cotangent is B over A. And those A's cancel and the B's cancel, and we're left with 1. We have just a couple more identities. You know, this is a lot of identities, but once we start to work with them, it'll be a little bit more comfortable. These are called our quotient identities. Tangent of theta is sine of theta over cosine of theta. You're like, well, why is that true? Well, let's start with sine theta over cosine theta. And we know in a given right triangle, sine of theta is A over C, and cosine of theta is B over C. And we can multiply the top and the bottom by C over B. The B's cancel and the C's cancel. These C's in the numerator cancel. We get A over B. Well, what was A over B? Tangent of theta. So tangent of theta is sine of theta over cosine of theta. And similarly, cotangent of theta is cosine of theta over sine of theta. And so let's work on an example. Here we have a right triangle. Theta's here, our square root is, or our square 90-degree angles here. We have 3, B, and 1. Find all 6 trig functions of theta. I don't know why I wrote it out, but that's our theta. So we need sine theta, cosine theta, tangent of theta. And sine is so, opposite over hypotenuse, 1 over 3. Cosine is adjacent over our hypotenuse. Say, well, adjacent is a B, and our hypotenuse is 3. Well, we can use our Pythagorean formula, which says that B squared plus 1 squared equals 3 squared. So B squared is 3 squared is 9 minus 1 is 8. So B is the square root of 8. Which means then cosine is the square root of 8 over 3. And tangent then is TOA, opposite, 1 over adjacent, square root of 8. And if that's correct, we should be able to say, well, tangent of theta is sine theta over cosine theta. Well, that's a third over root 8 over 3. Slide that up a little bit. 3 over root 8 times 3 over root 8. Those cancel, TOA 1. 3's cancel, 1 over root 8. Checks out. And then we have our cosecant, which is just our 1 over sine theta, or a reciprocal of 1/3, which is 3. Our secant of theta is 1 over cosine of theta, 3 over the square root of 8, and cotangent of theta is 1 over tangent of theta, square root of 8. So whenever you have a triangle like this, if you have a missing side, you need to first use the Pythagorean theorem to find the value. And then you can find sine, cosine, tangent and use your reciprocal functions, or you can work the other way, whichever seems more natural to you. Now, there are a couple special triangles. So some special triangles. We have our 45, 45, 90 triangle, which is called because we have, I'm going to try to draw this as to scale as possible. This angle is 45 degrees. This is a right angle. This angle is 45 degrees. If we make this side unit length 1, Sides opposite, congruent angles are congruent, so this one is also 1. 1, 1, and the length of the hypotenuse is the square root of 2, because 1 squared plus 1 squared is 2, and that equals c squared. C equals the square root of 2. So if it says find the sine of 45 degrees, the cosine of 45 degrees, and the tangent of 45 degrees, you need to draw your 1, 1, root 2 triangle. Sine, pick opposite hypotenuse, 1 over root 2. Cosine, we get different colors. Adjacent over hypotenuse, 1 over root 2. And tangent, opposite over adjacent, 1 over 1, or 1. So you need to commit to memory our 1, 1, root 2, our 45, 45, 90 triangle, and one more special triangle. Our second special triangle is our 30 degree, 60 degree, 90 degree triangle, which looks something like this. We have 30 degrees here, 60 degrees here, and 90. We have a 1, a 2, and a square root of 3. Confirm that works. Root 3 squared plus 1 squared should equal 2 squared. 3 plus 1 equals 4, and it does. And if you're given these, we can find all of our functions. So say find cosecant of 30, secant of 30, cotangent of 30, sine of 60, cosine of 60, tangent of 60, cosecant of 60, secant 60, cotangent of 60. Oh, I skipped one too many lines. So, get our handy dandy reference sheet, and I will, generally speaking, recommend that you go ahead and make one of these reference sheets. It looks like this. So cosecant of 30 is hypotenuse over opposite. So we have hypotenuse 2 over opposite is 1. Secant of 30 is hypotenuse over adjacent, hypotenuse over adjacent. Cotangent is adjacent over opposite. So sine of 60 is opposite over hypotenuse, root 3 over 2. Cosine of 60, cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is hypotenuse over opposite. Hypotenuse over opposite, 2 over the square root of 3. Secant is hypotenuse over adjacent. Hypotenuse over adjacent. Cotangent is adjacent over opposite. And you'll notice we see some interesting relationships appear. So secant of 60 equals cosecant of 30. Or we have tangent of 60 equals cotangent of 30. And these relationships actually give rise to what are called the co-function identities. Co-function identities. sine of theta is the same as cosine of 90 degrees, or pi over 2 minus theta. Cosine of theta is sine pi over 2 minus theta. And where does that play out? Well, here we said we see this with cosecant and secant. So let me give you that one. Secant of theta equals cosecant of pi over 2 minus theta. And cosecant of theta is secant pi over 2 minus theta. So our 30, 60, 90 is our pi over 6, pi over 3, pi over 2 triangle. And so this identity tells us that cosecant of pi over 6 equals secant of pi over 2 minus pi over 6. Well, pi over 2 minus pi over 6 is pi over 3. So that tells us that cosecant of 30 equals secant of 60, which is precisely the equality that I pointed out here. So the last of the identities for today, and I know that this is a lot because there are a lot of different identities. So we have tangent of theta is cotangent pi over 2 minus theta. And cotangent of theta is tangent of pi over 2 minus theta. But we're going to be working with these identities a lot over the next few sections. So it's important to see where the things that I want you to remember from today are given a triangle, how to work within it, finding its trig functions. Know the relationship SOHCAHTOA, and that sine's inverse is cosecant, cosine's reciprocal is secant, and tangent's reciprocal is cotangent. And we have two special triangles, our 30, 60, 90, and our 45, 45, 90. I know this is a lot, but we'll work with it and they'll be more comfortable as we go. Have a great day, everybody.